equations of motion to determine the position, velocity, and displacement of a projectile at any given time. Let us use the equations of motion to determine the position, velocity, and displacement of a projectile at any given time. Eric is moving vertically upwards at a constant speed of 4,9 meters per second in a hot air balloon. A bag is accidentally dropped by him when the balloon is exactly at a height of 58,8 meters from the ground. The bag strikes the ground after 4 seconds. Find the position of the bag at time delta t equal to 0 seconds, 0,5 second, 1 second, and 4 second. Solution. As we are dealing with displacement, velocity, and acceleration, all of which are vectors, it is necessary to choose a direction as positive. We choose the upward direction as positive. This is the positive direction of displacement, velocity, and acceleration. The position of the bag is always measured with respect to some reference point. The reference point for calculating the position also needs to be chosen, which we shall do later. Here the total time of flight of bag delta t total equals 4 seconds. The initial velocity vi equals 4,9 meters per second. The height from which the bag falls is 58,8 meter. Acceleration due to gravity, g, is in the downward direction, hence negative. At delta t equals 0 second. Delta y equals 0. At delta t equals 0,5 second. Delta y equals 1,23 meter. At delta t equals 1 second. Delta y equals 0 meter. At delta t equals 4 second. Delta y equals negative 58,8 meter. Hence the displacement of the bag after 4 seconds is 58,8 meters in the downward direction. Let us choose the ground as our reference point for determining the position. We know that at delta t equals 0 seconds, the ball is at a position positive 58,8 meters from the reference point on the ground. We call this y0. We know that displacement is the change in position from the starting position. Hence, the position of the bag with respect to the ground at different times can be calculated. Position at delta t equals 0 second is y equals y0 plus delta y equals 58,8 meters. At delta t equals 0,5 seconds, y equals 60,03 meter. At delta t equals 1 second, y equals 58,8 meters. At delta t equals 4 seconds, y equals 0 meters. Now the velocity of the bag at delta t equals 0 seconds, vf equals vi plus g delta t equals 4,9 meters per second. At delta t equals 0,5 seconds, vf equals 0 meters per second. At delta t equals 1 second, vf equals negative 4,9 meters per second. At delta t equals 4 seconds, vf equals negative 34,3 meters per second.
Starting to feel it? Now go master it with Maski.